Alright, this is a review of week 12, BCA-101. On Monday, we did a generic review of units 5 and 6. So we talked about some key things. We talked about internet service providers in the ICN. We talked about here at the college, the device connected in. We talked about the idea of a firewall. Blocks anything trying to come in, but if you had traffic going out, then it's going to let that same kind of traffic back in. We talked about devices connecting, phones. Talked about student records here on campus, accessing a web server, and so forth. Remember, we mentioned data was the asset, and we talked about those things in terms of protecting data, and then we said you got to check your risk to decide what kind of efforts you're going to make to protect the asset. Some people move the assets out to a cloud, and then everybody's happy. You put it out here and let them worry about backing it up to hard drives and so forth. And then you just pay them to do that, okay? Or you do it yourself, locally, however you might manage that. And the same thing's true on devices and how you manage that. We mentioned a few things about the internet, all those routers connected, communicating with each other in the internet, allowing us to communicate with a cloud back to us, for example, here at NIACC, or, pretty much anywhere somebody allows you access through an ISP into the cloud, or into the internet, which is a cloud itself in some ways. I asked what was the key thing that you pay for when connecting to a provider. Is bandwidth. Now, that's typically then bits per second. There's another way you can pay. You can pay by the data rate. For example, we have a 1 gig plan, LTE, and then you pay, connecting to a tower. And this would be like phone or mobile devices, okay? And then we went through a little bit. Yeah, US Cellular, we have 1 gig. We went through a little bit, reviewed again, modem, Mediacom, then you have maybe a routing device at your location. You can hook up a PC, you can use Wi-Fi, maybe a laptop or phone. In here, you have your private address, and that private address then is converted to a public address before it goes out on the internet. Public address is given to you through your ISP. It's called logical address again because it changes depending on where you are. If you're in a hotspot sometime at a coffee shop, you'll get a private address down here, but it'll be changed to a global when it goes out the ISP. And what global address or public address that it will be will depend on the ISP. We talked about how we secure, we authenticate somebody, we authorize what they can do, and then we keep track of what they did. Authentication, authorization, and auditing or accounting. Difference between encryption and hashing. We encrypt and decrypt. Hashing, we can take it and it makes a fixed set here that cannot be unhashed. But the only way to unhash that would be to guess what the word was and then hash it and see if it matches. Used a lot for passwords. Okay, and this is to guarantee confidentiality of the material when it's being transported. You can also hash material, send it to another location, and send the material and the hash to another location, they can hash the material and match the hashes to verify that it hasn't been changed. Last unit, Unit 7, talks about information systems. Communications and information systems. So what we look at is we want some common terminology, or common terminology, I should say. So we talked about a business. Our reviewed business might have a board of directors. For example, here at the college we have the board, we have our president, we have VPs, and division chairs. Okay? We call these first line supervisors. They deal directly with the workforce primarily. Then we have middle management. They report to top management and help first line supervisors do their job. Top management, they have concerns for the entire company as a whole. And then you have the workforce. For example, this here is me. Okay, somewhere's down there in the workforce. I see to my division chair, and they see to the VPs. The VPs see to the top. Top guy has to be responsible to the board. Top gal or guy, however you might want to think of it. Thinking about long range, think about tactical things day in and day out. Okay? The triangle gets smaller because there are typically less people as you move up. There might be quite a few division chairs, less VPs, and up here there's really just the president. We compared that to levels of information. We started down here, we build a huge or small database. We build these tables, and they all relate to each other. You have information from one table relate to another table, relate to another. That's why we call it a relational database. And we looked at this. What do we do in terms of information? We take information from the database management system and we move it up. And we here, during a transaction, there'd be lots of information at the transaction. The school example, we talked about taking attendance. Okay. Here, we might pull one record out of the attendance and see how attendance is doing for this week or maybe the month. Okay. Up here, the CEO or the president of the college might want to know what attendance is for this last year, maybe, and then where is it currently, and where was it the trend over the last 5 years. Okay, so he or she doesn't want to know the exact attendance. They just want the trends. So this data, as it moves up, we get less data, but it's more geared towards whatever they have to do. Strategic planning, long term, tactical planning, short-term decisions. Traditional is day in and day out. And so we gave a business situation. You work some hours, you turn those hours in. That's like a transaction. That information goes in the database and then comes back and it creates a paycheck for you. All right. So you can start to see how these would relate. Top level people are more interested in strategic information. Middle level, more the tactical information. First line supervisors are concerned with transaction or the day in and day out. Again, the triangle represents less people here, less actual information up here, but more summarized or designed for the specific need of somebody. Couple slides left. What do we use information for? Well, one of the main things we're going to talk about are decisions. There can be a structured decision, semi-structured, and non-structured. Structured decisions are very straightforward. When you give your hours and it calculates your pay, it's very structured. There's no, like one day if you work 10 hours you get one pay, another day a different pay. No, it's very structured. There's an algorithm that figures it out. Okay? We asked in class how many students had automatic deposit or, received checks. We had about 50-50. This is a task, structured tasks, that very typically can be done using technology, because there's really no gray areas. A computer can be programmed to figure out pay. Okay, a computer, if it knows where the cutoff is, can be programmed to order more products when it needs to. It can give you the sales report for the month. It can, etc., etc., etc. So, structured decisions, ones that the technology can do it for us. Semi-structured, a little different. Like the computer can order a product as long as you maybe figure out where that cutoff line is based on other data. Okay, so it's still structured, but not as structured where there would be more human interaction. Non-structured tend to be decisions that have they can be data driven, but a human typically makes the decision. Okay, who to hire, who you're going to hire. You may gather lots of data. You might have been able to have a computer eliminate certain people based on their qualifications. You might do another cut here based on something else. But then when it comes down to actually hiring, you'll probably interview, and that would be a non-structured. What color of material are you going to use for something? How much of what are you going to produce? You can have lots of data, but a human might make that non-structured idea. Towards the end of the course, we talk about artificial intelligence, which attacks or attempts to do some of this work for us. And now the last part, okay? So, previously we'd shown that relational database. So what we did as a class here, we looked at an example of databases. We started out, we store data. Data are ones and zeros, so these ones and zeros using the ASCII code represent an A. That's text. We can use some other code to represent a number. That's numerics. We can take that and store it, the information, into a database, a way to organize it so we can access what we need. So the first example we came up with here was we have text, so we stored first name, and then we gave that a field name and another field name. Typically we'll call those attributes. They define something, and in this case they're defining an instructor, so we're going to call this the instructor table. These are data items. You put a bunch of data items together and you get a record. Put a bunch of records together and you get a file. Or what we will call, in these cases, we get a table of data. Now we have to have a special way to identify each person, so we created a field here called a primary key. A little hard to see, but that's a primary key. Okay, so this field is a primary key. So the instructor ID, in this case, will always be unique here. Just like up here we created a student ID, that would always be unique. Or a course ID, those would all be unique. Okay? A term ID, so these terms would be marked, that would be unique. So then in here, I created a courses table. This has all the information about the courses. Course ID, and then name, credits, and then I put in here instructor ID, who is teaching the course. We have student table, and we have name, and you have a whole bunch of information. Then I put city, state, zip. Okay, and then we talked about Mason City would be repeated a lot in the table, so what we could do is we could put this in another table and just put the zip code in. And then if we needed to know Mason City, Iowa, we could always refer to that other table. Reduce some redundancy. And then during the term, we can put in term ID, we have a date, student ID, course ID. Okay? We put those in here and use a course ID. And so we know this student is taking this course. So, student IT is the primary key from this table. So when we use it here, it's called a foreign key. Course ID, primary key here, we use it in another table, it's called a foreign key. And the same thing here. Here it's a primary key, down here in this table, it's a foreign key. So that's a good start on databases, and that would be it for today.